Hello all, let's solve another Leetcode problem. And the question for today is find the first and last position of an element in a sorted array. I would suggest taking a couple of minutes and going through the problem. So we have a sorted list and a target element, and we need to find the first and last occurrence of the target element. And the first thought might be to do a linear search, but the problem clearly specifies that we can make use of the fact that it's sorted and do it in O of log n time complexity. So the natural approach would be a binary search. And through binary search, we can eliminate our search space and greatly reduce the amount of time it takes to search for a certain element. Let's have a look at an example and see how we can approach this problem. So we've got 6 elements, 5, 7, 7, 8, 8, 10, and let's say the target we're looking for is 8. Let's think of how we would solve it using normal binary search. Let me write down how the basic algorithm for binary search looks like. So we have a start and end, and we iterate while start less than or equal to end. Mid will be start plus end by 2. And then if, let's say our input list is nums and our target is t, if it's greater, then we can eliminate half of the list. So end will be equal to mid minus 1. The other condition is if it's lesser. Then we can eliminate the first half. So start mid plus 1. If it's equal, we found our element. So we can just return mid. Let's apply this to our problem. So our start would be at 0, end would be at 5, our mid would be 5 by 2, which is 2. We see that the number at index 2 is 7, which is less than 8, and we can eliminate the first half of the list. Now our start can be here, and our end remains at 5. Now again our mid is 3 plus 5, 8 by 2, which is 4. And in a normal binary search, we could have just returned it. But in this case, we want the first occurrence. So index 4 is clearly not the first occurrence. There's an 8 at index 3 as well. So to accommodate for this scenario, we can just modify our existing binary search algorithm a little bit to make sure that we don't end the search and continue in this case. We can just modify the first condition as follows. We do or nums of mid equal to target and nums of mid minus 1 also equal to target. So in this case, what happens is we don't end the search here, but because nums of mid is equal to target and the previous numbers also equal to target, we reduce or move back our end pointer. So our end pointer is here. Now 3 plus 4 by 2 is 3. So we arrive at mid is equal to index 3. And this is our first occurrence. Similarly, we modify our second condition to look for elements after it rather than ending it right there. So we modify it as follows. Or nums of mid equal to target and nums of mid plus 1 is also equal to target. So in this case, we know that there's an element after this which is equal to target, so we move our start pointer forward. By making this small tweak to our existing binary search algorithm, we can find the first and last occurrence of the element, and that basically solves the problem. And since we're not using any extra space or time. We are doing binary search. It's just that we're doing it twice. So the time complexity would still be O of log n, and it would be constant space, or O of 1 space complexity. Let's go ahead and jump into Leetcode to solve this question. So we have a function called search range with nums and target as the inputs, and we need to find the first and last occurrence of target. So as an edge case, let's see if nums is empty, then we can just return -1. Now we need to find the first and last, and we'll be using similar binary search code, and rather than repeating it twice, let's use a helper function and call it search, and it needs nums, target, and the type of search, whether we're looking for first or last. Let's just call this occurrence. We need a start and end pointers, which will be 0, length of nums -1. And our looping condition is while start less than or equal to end, mid equal to start plus end by 2. And our first condition here can be if nums of mid greater than target and equal to mid -1. This would be a normal binary search, but we also want to accommodate for finding the first and last occurrences. So let's add the other condition here, or occurrence equal to first and nums of mid equal to target. And if we want to move our end pointer before mid, we want to make sure it's not 0. So and mid greater than 0 and nums of mid -1 equal to target. So in this case, end is mid -1. The other condition is when we want to find the last occurrence. And firstly, if nums of mid is less than target, or and when we're trying to move our start pointer forward, first we just check if nums of mid and we also want to make sure that mid is not equal to length, so it's within our range. And nums of mid +1. In this case, it means that there's one more target element after this. So start is equal to mid +1. And the else case, we can just return mid. If we go through this entire circle and don't find anything, then we can return -1. Now that we have this helper function where we just pass in nums, target, and the type of occurrence we're looking for, which is first or last, we can simply find these occurrences by calling this self.search nums target. Let's call this first. And for last, we just do the same thing. So we have both of these. So now we can just return our result, which is the first and last indices. This might look like a big condition, but all we're doing is when we're finding the first occurrence, we're checking if mid is equal to the target. And if there's a neighboring element on the left that's also equal to the target, we don't want to end the search, but actually move the end pointer back. And similarly, we're doing this when we're trying to find the last occurrence. Let's run this code to see if it works for the given example. Yes, it does. So 3 and 4 are the first and last occurrences of 8. Let's submit this code to see if it works for all possible inputs. Yes, it does. So from this solution, we can observe that slight changes to the basic binary search algorithm can help us solve different problems or variations. Hope you found this helpful. Thank you.